After getting introduced with .NET Framework in last session, now it's perfect time to get started with C#, the de facto language to work on .NET platform. Before starting with session, make sure that you have installed Visual Studio 2012 on your PC. If not, just download the Express Edition and install. Express Edition is freely downloadable from Microsoft website. Let us have a quick look on agenda. We will start with traditional Hello World program. Obviously, we will see how to compile and execute it. We will see how to use variables, CTS data types and its categories like value type, reference type. We'll also see some other data types like string, dynamic, object. We'll have a look on type inference, typecasting, boxing, unboxing and constants. In the end, we'll write a small program to read keyboard inputs using Console.ReadLine. Fine, our first program is none other than Hello World. Let us start writing programs step by step. We know that every program starts its execution from main method. Main method in C# will look like this. Don't worry about the static keyword at this point. Now to print Hello World on console, let us use Console.WriteLine method. We can correlate it with printf of C. But in .NET, every method resides in some class, and here WriteLine method resides in console class. That's why simply calling WriteLine will not work, and we have to call it as Console.WriteLine. We are passing Hello World string as a parameter to this method. Obviously, it will print it to console. We can also add one more line to this program, that is Console.readKey. This method will hold the output screen till you press any key on the keyboard, giving you chance to view the output. In C, to accomplish same thing, we generally use getCh. Now it seems that we have completed our first C# program. But wait, still it is incomplete. C# is pure object-oriented programming language and don't allow global methods. Every method has to be in class. So here, let us include this method inside class first program. But still it's not complete code. In C#, every class resides in namespace. So you need to specify same here. Say Hello World is the namespace name over here. If you will not specify the namespace name, then compiler adds default namespace. This unnamed namespace sometimes referred as global namespace. Now we also need to include small statement using system at the top. As we have seen that every class resides in some namespace. Same way console class resides in system namespace. That's why to use console class, we need to first import system namespace in our program. In the end, we can also add comment to describe the program. This is one line comment in C#. Comments are for programmers or source code readers. These are always ignored by compiler. With this, our first program is ready and we can compile and execute it. Let us assume that this file is saved as firstprogram.cs. Then we can compile it through command prompt using command CSC, stands for C# compiler, and can execute just by calling the exe. So I have written this firstprogram.cs using notepad and saved it in some folder, and I wanted to compile it using command prompt. So what I can do, I can use Visual Studio 2012 tools, this command prompt. Here I need to go to that location first. So fine. Now C# compiler space and name of the program, first program.cs, enter, and C# compiler will compile your program to exe. This exe you can simply call first program, remove that .cs, you can simply say first program or first program.exe, whatever, and you will get output on the console. So this is how you can compile your program using your command prompt. Or you can simply compile and execute using Visual Studio. Just click on start button over here and Visual Studio will compile and execute it. Press any key to return back. Here you can see that I have created one solution getting started with 13 projects. These are the all programs or projects that we are going to cover today in this session. Now, what is this solution? Solution is group of projects. This facilitates you to keep related projects at one place and make them manageable. You can simply add new project like this. Here you need to always specify project type. So select console application, give proper name, click on OK, and one new project will get added over here. Now you can see that this hello world is little bit dark. This means that when I will execute it from here, hello world program will execute. If you wanted to execute some other program, you just right click on that and say set as startup project. Now when you will execute this, second program will execute. Fine. So our second program is about how to use variables. We can't imagine programming language without variables. Variables are named memory location which can store any type of data. You can just imagine variable as a box holding some information, and that box itself has some name, frequently known as variable identifier, using which we can refer to specific variable. For example, A. This is what identifier. Information or values that we want to store in variable can be of different type and sizes. That's why variable can be declared as different types depending on the requirement of program. The declaration of that variable has to be done before we use that variable. Syntax to declare this variable is very simple: data type and then variable name. For example, int a or float b. Let us see one simple demo program to demonstrate the uses of variable. So let us declare three variables, number 1, number 2, result. You can visualize them as like this. Now let us assign some value to number 1, number 2. This statement will evaluate operation number 1 plus number 2 and will put the result in result variable. So result will get assigned with 30. Now we wanted to print this value. For that we'll use same statement, Console.WriteLine. But this time you can see that inside double quote there is result is equal to. It will get printed as it is, but you need to keep result variable outside of the double quote. That's why you are concatenating it using plus operator, and it will print output as result is equal to 30. I would like to show same it in your Visual Studio. See the output. Fine. Now I said that you need not to worry about this initial structure, because when you will add, say, new project, say demo program, this is a project name that I am using. Fine. Okay, you'll see that Visual Studio will insert namespace, class and main method for you. You can also observe that namespace name will be same as an project name that you have used. Now these are various using statements that Visual Studio have included, but you don't want it to use it in your basic program, so you can always remove them. While typing, use IntelliSense effectively. For example, if you wanted to type Console.WriteLine, typing CONSO is sufficient. Now to insert console, you need not to press tab, you need not to press space, or you need not to press enter key. You should press the next character that you want. For example, you want dot, so dot, it will insert console, dot, then right line, you can use lower arrow, directly insert bracket. Hello. Now with the basic understanding of variables, it's right time to understand different data types available in .NET. We know that in .NET all data types are defined by CTS, and same need to be used in all .NET languages. Every language have mapped these data types with different names. For example, int32 of CTS is mapped as an int in C#, whereas integer in VB.NET. These data types are categorized in two types, value type and reference type. Value type get created on stack, whereas reference types get created on heap and store references on stack. Every data type is derived from system.object class, either directly or indirectly. In this diagram you can see that every built-in reference type directly derives from object class, whereas value type derives from system.valueType, which in turn derives from system.object class. In short, ultimate base class is always system.object for each and every data type. C# has 16 predefined or built-in data types, out of which 13 are value type and 3 are reference type. User-defined data types can be created using keyword, struct and enum. Same way reference types can be created using keyword, class, interface, delegates, etc. To make things more clear, let us see this example. Here we will demonstrate some value types and reference type. Let us start with integer variable. When we will define any value type like integer, it will engage memory on stack. In .NET, integer is of 32-bit. If you wanted to store big number and integer variable is not capable to hold it, then you can declare long variable, which uses 64 bits to store the number. If you wanted to store floating point number, then you can use float or double. The difference is that float is 32-bit while double is 64-bit. To store character, we can declare character variable. But in real life, we frequently wanted to store strings. rather than characters. In C and C++, we need to define character array for that purpose. But here we get built-in data type string, and string type is reference type. So now here you can clearly see that what exactly reference type is. It's creating object on heap and putting its reference on stack. The most interesting thing is assignment. See, when we assign value type to other value type, actual value will get copied. For example, we have declared int g and we are assigning a to g. So actual value will get copied in g. While assignment in reference type behaves differently. Here, if we'll assign f to h, only reference will get copied over here, and h will start pointing to same string object. Also, when we will learn functions, we will see that by default value type passes parameters by value, while reference type passes parameter by reference. Fine, let us have a quick look on list of predefined value types. SByte is 8-bit signed integer, short is 16-bit signed integer, int is 32-bit signed integer, long is 64-bit signed integer. Byte is 8-bit unsigned integer. Unsigned in the sense it will utilize all the 8 bits to store number and not store sign, negative or positive. ushort is 16-bit unsigned integer, uint is 32-bit unsigned integer, ulong is 64-bit unsigned integer. Float 2-bit single precision floating point, double 64-bit single precision floating point. Decimal 128-bit high precision decimal notation, which generally used to save currencies. Bool represents true or false, and char represents a single 16-bit character, which is generally known as Unicode character. Now let us have a look on list of predefined reference types. String stores sequence of Unicode character. Object is ultimate base class for all data types, and dynamic is a new type which enables bypassing compile time type checking. Let us have a detailed look on these three data types. The string type represents sequence of 0 or more Unicode characters. For example, computer in double quotes. Equality operators are defined to compare the value of string objects and not references. It makes convenient to compare two strings simply using equality operators. One thing about string, you should know that strings are immutable. That means the content of string object cannot be changed after the object is created. But if you will try to modify the content, new object will get created. You can use @character to define verbose string. Verbose string doesn't process escape sequences. Generally, you need these strings to represent path. Let us clear all these points using this example. In this example, let us declare one string object S1 Microsoft. So you can visualize it like this. Then let us append .NET to S1. It will not append the existing object, but it will create new object as shown over here, and it will update reference with this new address. That's why we say that strings are immutable. They never modify themselves, but whenever we will do any modification, they create new object internally. What is the advantage of this behavior? Why strings are designed that way? To understand this, let us see one another example. Here, if I'll assign S2 is equal to S1, So obviously strings are reference type, so it will copy this reference and s2 will start pointing to same string object. Then I am assigning s2 is equal to logic and concepts. So as strings are immutable, it will not change this object. Otherwise what will happen? S1 content of S1 will also get changed, right? So as strings are immutable, it will create, this operation will create new object and will assign content to this new object and will update your reference accordingly. So this is the advantage of immutable strings. One more good thing about string is that equality operators are defined to compare the content of the string and not references. For example, to compare strings you can simply use equal to operator or not equal to operator. Here we are comparing content of S1 and content of S2. If they are same, then this message, otherwise this message. And the last thing that I would like to specify over here is @sign. We can create verbose or literal strings using this @sign. This we will need whenever we wanted to store path with backspaces. All backslashes will get ignored if you will prefix your string with @sign. The object type is an alias for system.object of CTS. We know that all predefined and user-defined types inherits directly or indirectly from object. As it is a base class for all data types, it can store value of any type of variable. Let us see one simple example to demonstrate use of object. Here obj is declared as an object. It contains null by default. Now let us assign integer value to it. This integer will get converted in object and will get stored on heap, and reference will get stored in obj on stack. Same way we can assign string value to it, or it can also be assigned float value, or we can also assign float value to obj. Every time it will create new object on heap with assigned data type and will update reference as shown. This is possible because of upcasting. Upcasting is assigning derived type to base type. We will discuss it in detail in inheritance session. C# 2010 introduces a new type, dynamic. Object of type dynamic bypasses compile time type checking. This means compiler doesn't care what type of value we will be assigning to it. In most cases it will function as an type object, but it is different than object type as it allows you to do any operations at compile time. In short, at compile time, an element that is typed as dynamic is assumed to support any operation. The advantage is that you do not have to be concerned about from where object gets its value. If the code is not valid, it will obviously cause runtime error. To understand it, let us see this example. One can easily get confused with object type and dynamic type, as both are able to store any type of data. Although at runtime they behave same way, but at compile time, dynamic keyword tell compiler to skip any type checking. For example, in this program, we have declared dyn as dynamic and obj as object and initialized by 1. If we will check the type, in both cases it will be the integer. But then if we will try to do any arithmetic operation on obj, compiler will not allow you and will give you compile time error, specifying that plus operator is not supported on object type. This is because at compile time compiler doesn't know data type of content of object, so it can't allow any operation on it. On the other hand, if we will do same operation on dynamic type, it will execute successfully. This is because dynamic keyword tell compiler to skip any type checking on variable dyn, and at runtime dyn is resolved as an integer variable, as we are assigning integer to dynamic, as we are assigning integer to it. And obviously plus operator can successfully execute on integer operands. Point to note that if we will assign some user defined data type to dyn which doesn't support plus operator, still compiler will not give any error at compile time, but program will crash at runtime. This is most important difference between object and dynamic type. Let us see one more new feature, type inferencing. Type inferencing can be done using var keyword. The var keyword instructs the compiler to infer the type of variable from right hand side value or expression. For example, if you will assign value say 10 to var I, then it will infer type integer for I and will declare I as an integer. As var infers type from right hand side value, it is compulsory to initialize variable at the time of declaration only. Again, one point I would like to clear that once you declare var a is equal to 10, a will get declared as an integer and you will not able to assign any other type of value to it. For example, a is equal to 10.5 will throw the error type mismatch. Only local variables can be declared as var. The inferred type can be built-in data type or an anonymous type or any user defined type. Here in this example, number will infer integer data type, while pi will infer as an float, e will infer as an double. Message variable will get declared as an string, whereas each true variable will get declared as an boolean. Simple. Nullable types are value types that are capable to store null value. They are declared using special syntax like data type question mark identifier, for example int question mark x. These variables are capable to store null value in addition to normal range. Nullable types can be very useful while reading data from databases, as database field can have null value. In this example, we are declaring num as nullable integer. So before doing any operation, we can always check that whether num has any value or not using hasValue property. While using null value, one more useful method is getValue or default. It is smart method. It returns either the value if available or default value if null. To be more clear, if num contains 10, it will return 10, and if it contains null, then it will return 0, as 0 is default value for integer type. This is useful to avoid runtime exceptions while using nullable values in mathematical operations. Typecasting is converting an entity of one data type into another. This conversion can be done in two ways: implicit typecasting and explicit typecasting. Implicit typecasting is automatically done by compiler. Typically, when we assign small data type to big data type, implicit typecasting happens. For example, here we have integer variable and float variable. When we are assigning a to b, a will get converted into float automatically first before assignment. This typecasting is known as implicit typecasting. Explicit typecasting need to be done if implicit typecasting is not supported. For example, when you wanted to assign big data types to smaller. Here you can see that we have one float variable and one integer variable. Now when we wanted to assign x to y, we we first need to convert x to integer value. One thing you should note over here is that value after point will get lost. So data can be lost while doing explicit conversion. Also note that this conversion we have done using typecast operator. We can also do it using int.parse helper method, convert class, or using as operator. Let us see this example to demonstrate various typecasting operators available. Here a is integer, b is double variable, and we wanted to do addition of a and b, and we wanted to store it back to c, which is double variable. Now while doing this operation, a need to be typecast to double, as plus operator can't work on different types of data. But here you can see that a will get converted automatically to double and you need not to do anything for it. This is what implicit typecasting is. Now if we have some integer variable t and we wanted to do same operation and wanted to store it to integer variable, then obviously we first need to convert b to integer, but this conversion will not take place automatically. We have to specify it explicitly using typecast operator, and this is what explicit typecasting is. Now let us do same thing using helper method. For example, if there is one string variable s1 and one integer variable I, we just wanted to assign value of s1 to I, we can parse it to integer using int.parse method. One more powerful option is available over there is convert class. Convert class comes with various conversion methods. One of it is toInt32 that we are using over here. You are just passing s2, which is string variable, to convert.toInt32. It will convert this value to integer and will assign to I. Same way there is as operator, but as operator only works on reference type or nullable value types. Here you can see that obj is of object type and str is of string type, and we are converting obj into string using as operator like obj as string. Now let us see the concept of boxing and unboxing. Boxing is a process of converting value type into reference type. For example, we know that object is base of all data types and we can assign any type to it. So here we are assigning int a to object O. This will copy value of object in heap. This conversion is known as boxing. You should also note that boxing is always implicit. No need to specify any typecasting operator. While unboxing is a process of converting reference type into value type. For example, we want the value of object O back in integer variable, say b. Then we need to write statement like b is equal to int O, and value will come back on stack. This process is known as unboxing. Note that unboxing is always explicit process and we need to do it using some typecast operator. Constant is a variable whose value cannot be changed throughout its lifetime. It must be initialized at the time of declaration only. Constants can be used to increase the readability of code by replacing magic number by meaningful identifiers. For example, instead of using 3.14 in source code, we can use pi. It also makes easier to modify the program. For example, if you have multiple occurrence of pi in program and you wanted to modify it from 3.14 through 3.1415, then you just need to modify the value assigned to pi at the top of program. This is very helpful in big programs with multiple files. Imagine if you have used number 3.14 30 times in big program of 5000 lines. Without using constants, it will be very difficult to modify it to some new value like 3.1415. One thing that you should know is constants are always implicitly static. Let us see simple example to demonstrate use of constants. Here you can see that we have declared pi as a constant float variable so that we can use it in expression like this. The advantage over here is that your program is now more readable than using 3.14 over here. Also, if you have used this multiple times, you can modify it at one location and change will reflect it to all the locations. Also, it will prevent you to assign some other value to that variable as we have declared it as a constant. Fine. Now let us write very first interactive program. Interactive in the sense where user will able to enter some values. Console.ReadLine is very basic method which you can use to read inputs from the user. It is a static method of console class and read one line keyboard input at a time. That means it reads a line when you hit enter key on the console. It always treats input as a string, so you need to typecast it in required data type. Let us use simple example to demonstrate use of Console.ReadLine. In this example, we will accept two numbers from user in variables number 1 and number 2 and add it to result. So let us first declare the variables. Then we wanted to intimate user to enter first number. This can be done by using Console.Write method. Here you can see I am using write instead of WriteLine. Write method will not insert new line character at the end of your message and your cursor will be just in front of this line. If you will use WriteLine, your cursor will go to the next line on the console. As I wanted cursor blinking over here after this message, I am using write method. Then Console.ReadLine will actually hold down the control till user enters the value and hits the enter key on the console. Say user have entered 25 and hit enter key. Console.ReadLine will read it and will pass that value to convert.to in 32. This we need to do because this value will be in string format and we wanted to assign that value to integer variable. So before assignment we need to convert that value into integer. Next statement will ask user to enter second number and same way Console.ReadLine will read input and will assign it to number 2. Now as we have both the number, we can write expression result is equal to number 1 plus number 2. And this will add two numbers and will place it into result variable. Finally we wanted to print the result on console. That we can do using Console.WriteLine. Here you can see that we are using slightly different syntax. We are passing 4 parameters to Console.WriteLine method. First parameter is format string with numbered curly braces. These are known as placeholders. Second parameter is number 1. Third parameter is number 2 and fourth is result. Console.WriteLine will print plus and equal to as it is, as they are normal strings, but placeholder have special meaning. This first placeholder will get replaced with value of number 1. This placeholder will get replaced with number 2 and this with value of result. With this, you are now very much familiar with two basic input and output statements, that is Console.ReadLine and Console.WriteLine. I would like to stop here. Thank you.